Hi there, this is a video about a trapezoid, and what we're going to do is prove some things about the midsegment, and we're going to use a coordinate proof. So let's first take a look at how I constructed the trapezoid. Because the definition of a trapezoid is parallel bases, I'm using the x-axis to place one of the bases, and that will keep a consistent slope of 0, and so I use a horizontal segment for base 2. This will make most of the calculations easier during the coordinate proof when we're working with 0 slope. Alright, so what is a midsegment? A midsegment is connecting midpoints of the legs. So what we have here is the two legs and the two bases. And remember, the bases by definition are parallel. So as we find the midpoints of the legs, we will connect them. So let's start by calculating those midpoints. Our midpoint definition is, you could think of it as the average of the x values. We're going to add the two x values and divide by 2. And for this leg, the x values I'm talking about are of the points P and Q, the endpoints of this leg. So this would be x1 and x2, or vice versa. Addition is commutative, so we could do this in either order. The second part is the average of the y values. So we have y1 plus y2 divided by 2. And when I'm talking about average, more specifically, we're finding the mean. So I would now be adding the two y values and dividing by 2. So let's find and prove the coordinates of this midpoint. We have 0 plus 2a over 2, 0 plus 2b over 2, and when we simplify, we get our coordinates a, b. And now let's solve for the coordinates of this midpoint, for this leg. We have c plus 2d and c, and 0, 2b. And here we have our coordinates of midpoint n. C plus d is the x value, and b is the y value. And yes, certainly there was some thought that went into choosing the expressions to represent our x and y values, understanding the nature of midpoint, that its x value will be halfway between these two x values. I did think about choosing c and c plus 2d in order to get c plus d, which makes calculating other distances and measures a little easier. Now that I have the coordinates of our midpoints, what I want to do now is prove that the slopes are the same. And the way I constructed this trapezoid, I know ahead of time that I will get a 0 slope here, but let's go ahead and first let's solve for the slope of PS. So for base 1, slope is rise over run, or the difference in y values over the difference in x values. And so let me substitute y2 and y1 for the slope of PS, and x2 and x1. And we see that our numerator becomes 0 when we're finding the slope of a horizontal. And so no matter what our denominator value is, as long as it's not 0 also, which it's not because distance is always positive, so we know this is a positive measure, we will get a slope of 0. And now let's get slope of base 2, QR. So for my change in y value, I will subtract 2b from 2b, and for change in x, c minus 2a. Again, this distance is always positive. Our numerator becomes 0, so we have again shown algebraically that our two bases are parallel. And now we will find the slope of our midsegment. Again, our denominator is the difference in x values, and we do get a positive measure because distance is always positive in geometry. Our numerator is 0. Again, we have a 0 slope, so we've just proven the first part of our midsegment theorem, which is that the midsegment is parallel to the two bases. And now for the second part of the theorem, we want to prove the distance of the midsegment in relationship to the sum of the distance of the bases. So what I've done is reflected these distances exactly 180 degrees around this midpoint n. So now what I have down here is the same distance as this base, and this base was rotated and is now over here. So what we can do is now consider this, which is a parallelogram, by the way, and this is also a useful visual proof when we're starting to look at area. But for now, just if we think about this distance as if this is base 1 and base 2, this whole distance is now that sum, b1 plus b2. And because this is a parallelogram now, And we've proven that these are all parallel. When I do this 180-degree rotation, these continue to be parallel. And one of the properties of parallelograms is that opposite sides are congruent. And this segment being parallel is also congruent to these. So this would also equal 2 times the midsegment. And when I say the midsegment, I mean its length or distance, because this distance was rotated here. So if this is my midsegment distance, this is another one. And so that's 2 midsegments. And this is a cool way maybe to look at the formula, which is the distance of the midsegment is the sum of the two bases divided by 2, or the average of the two bases.